The star Betelgeuse, a red supergiant located in the Orion constellation, has long captivated astronomers and sky watchers alike due to its enormous size as well as its brightness. If Betelgeuse were situated where the Sun is, it would extend all the way to the orbit of Jupiter, showcasing its immense dimensions. Despite being approximately 642 light-years from Earth, its sheer size makes it one of the most brilliant stars visible to the naked eye. In recent times, however, Betelgeuse has displayed some peculiar activity, including unexpected dimming and brightening cycles, which many scientists believe may indicate that the star is nearing the end of its life. The renowned physicist Brian Cox recently made a groundbreaking declaration. Betelgeuse is on the verge of a devastating explosion that is anticipated to take place within the next 2 weeks. This event, known as a supernova, will mark the final stage of Betelgeuse's existence but will present an extraordinary opportunity for scientists to examine one of the universe's most powerful and spectacular phenomena. As a huge star gets closer to its end, Betelgeuse is classified as a red supergiant, one of the largest and most massive types of stars in the universe. It has been under observation for centuries, but its recent erratic changes in brightness have sparked speculation that it may soon go supernova. When a star like Betelgeuse reaches the end of its life, its core collapses under the immense pressure of its own gravity, resulting in a massive explosion that releases an incredible amount of energy, radiation, and stellar material into space. Betelgeuse's imminent explosion is expected to be a Type II supernova, a specific kind of stellar detonation that occurs when the core of a massive star collapses. This core collapse triggers the release of neutrinos and radiation, creating a shockwave that disintegrates the star. The explosion will be so intense that it may even be visible from Earth without the need for telescopes, possibly even outshining the moon in the night sky for several weeks or months. While such an event would normally be destructive if it occurred closer to Earth, the distance between Betelgeuse and our planet, around 642 light-years, means that, although the explosion will be dramatic and visible, it won't pose any risk to life on Earth. However, this occasion promises to radically alter our perception of cosmic and supernova phenomena. A supernova is one of the most energetic occurrences in the universe, releasing more energy in just a few seconds than our Sun will over its entire lifespan. Betelgeuse's explosion will not only be a dazzling celestial display but also an invaluable scientific event. Researchers are eager to monitor this rare incident from the very beginning, utilizing various ground-based and space-based telescopes, such as the Hubble Space Telescope and the James Webb Space Telescope, JWST, to collect as much data as possible. When Betelgeuse explodes, it will emit a wide spectrum of radiation, ranging from visible light to gamma rays. One of the most critical aspects of the supernova will be the flood of neutrinos, elusive subatomic particles that seldom interact with matter. Neutrinos from a supernova can actually arrive on Earth before the light caused by the explosion itself, due to their ability to pass through nearly everything without being affected. Observatories like Japan's Superkamiokande and Antarctica's IceCube Neutrino Observatory are preparing to detect these neutrinos, giving scientists an early start in observing the final moments of Betelgeuse. Additionally, the explosion will offer crucial insights into the formation of heavy elements. When stars go supernova, they forge and release elements like iron, gold, silver, and uranium, materials essential for life as we know it. The study of Betelgeuse's supernova will allow researchers to observe this element creation process in real time, which is vital for understanding how planets and the universe's chemistry come together. Although Betelgeuse's supernova is not expected to have harmful consequences for Earth, it will likely interact with our planet's atmosphere and magnetic field in fascinating ways. The energy burst from the explosion, particularly the arrival of cosmic rays and charged particles, could generate stronger auroras, expanding the regions in which the northern and southern lights are visible. While these cosmic rays could potentially interfere with satellite communications and some technologies on Earth, any minor disruptions are anticipated. One of the most exciting aspects of Betelgeuse's explosion is that it will be visible to everyone on Earth, not just professional astronomers with high-tech equipment. For weeks or even months, Betelgeuse is expected to be the brightest object in the night sky, possibly even visible during the daytime. Not only will this spectacle captivate the scientific community, but it will also engage stargazers and the general public, sparking renewed interest in astronomy and the cosmos. Astronomers have long speculated about the death of Betelgeuse, but Brian Cox's recent statement accentuates the urgency of the situation. In the coming weeks, observatories around the world are preparing to study every stage of the supernova, and the data collected will be priceless, potentially transforming our understanding of stellar evolution, core collapse supernovae, and the distribution of cosmic matter. Betelgeuse's supernova will also provide a rare opportunity to refine our models of cosmic distances. Being relatively close to Earth, it offers an unparalleled chance to observe how energy from such an explosion travels through space. By studying the light and radiation from the supernova as it interacts with the interstellar medium, the gas and dust that exist between stars, astronomers will gain a clearer picture of the universe's scale. This event will also provide a golden opportunity to investigate dark matter and how it may influence supernovae. Dark matter, the mysterious substance that makes up about 85% of the universe's mass, doesn't emit or absorb light, making it difficult to detect. However, observing how light and matter behave around Betelgeuse after its explosion could provide indirect clues about the role dark matter plays in shaping the universe. Betelgeuse's supernova will also take us closer to understanding the life cycle of stars, especially how massive stars contribute to the creation of the elements necessary for life. Supernovae are the primary cosmic events responsible for spreading heavy elements throughout the universe, elements that eventually form new stars, planets, and even life. By studying Betelgeuse, scientists will obtain crucial data on how these components are made and distributed. The cultural significance of Betelgeuse's explosion is profound. Humans have looked to the stars for millennia for guidance, inspiration, and even meaning. The disappearance of one of the most visible stars in the night sky will prompt philosophical reflections on the transient nature of the universe. Betelgeuse has been a constant fixture in the constellation Orion for as long as humanity has observed the stars, and its absence will serve as a powerful reminder of the impermanence of all things. In some cultures, such celestial events have been seen as omens or signs of cosmic change. Betelgeuse's explosion may evoke a mix of awe, fear, and wonder, as people from all walks of life witness a star's passing. As the countdown to Betelgeuse's anticipated supernova progresses, global attention intensifies. Major space agencies, NASA, ESA, and JAXA, are coordinating efforts to capture every possible detail. Specialized instruments are being calibrated, data-sharing agreements are being finalized, and backup systems are ready to ensure no single moment is missed during this once-in-a-lifetime stellar finale. In addition to the scientific community, educational institutions worldwide are incorporating the event into curricula. Classrooms are turning their eyes to the stars. Students, from elementary school to university level, are now participants in a global scientific moment. Lessons on stellar evolution, spectroscopy, and the role of supernovae in cosmic enrichment are coming alive in real time. Children today will grow up saying, "I remember when Betelgeuse exploded." Beyond the science and the classroom, artists, poets, and philosophers are also finding inspiration. Throughout history, the cosmos has served as a mirror for the human spirit, its vastness reflecting both our awe and our vulnerability. The death of a star like Betelgeuse stirs questions of mortality, rebirth, and purpose. New works of music, literature, and visual art are already emerging, celebrating the majesty and final breath of this ancient celestial giant. For indigenous cultures and ancient skywatchers, stars have always held meaning beyond astronomy. In some traditions, a supernova is seen as the death of a great ancestor, their light traveling across time and space to say farewell. Betelgeuse's demise will likely echo in sacred storytelling, connecting ancient wisdom with modern discovery. Meanwhile, space tourism companies are already preparing public viewing packages. From high-altitude balloon flights to observatory retreats in remote deserts, people will be able to witness Betelgeuse's light show under the clearest skies possible. It may become the first cosmic event with global viewership, shared simultaneously across continents via live streams and immersive virtual reality. Even theologians and spiritual leaders are weighing in, framing the supernova within broader existential discussions. What does it mean that a light which has shone for millions of years is reaching its conclusion during our era? Some will see it as coincidence, others, as a cosmic message. Whatever one's interpretation, one fact remains clear: Betelgeuse is about to make history. Its explosion will mark a milestone in human observation of the universe, fusing science, culture, and shared human wonder into a singular moment. In the coming nights, when you look up at Orion and see the red glimmer of Betelgeuse, still burning, still defiant, remember that you are witnessing the final breaths of a titan. Soon, its light will flare, blaze across the sky, and then fade. But in its fading, it will seed new beginnings, of thought, of stars, of stories. Betelgeuse is dying. But in doing so, it will illuminate our universe like never before. Destruction that governs the cosmos, a reminder that new stars emerge from death. Planets and even life can emerge. As we await this monumental event, the world will be gazing at the sky at night, anticipating the moment when one of the universe's most powerful forces bursts into view. For both scientists and stargazers, Betelgeuse's final act will be nothing short of awe-inspiring. As Betelgeuse approaches the final stage of its life, one of the more speculative, yet intriguing, possibilities surrounding its impending explosion is its potential to shed light on some of the universe's greatest mysteries, dark matter and dark energy. These elusive forces are believed to account for the vast majority of the mass and energy of the universe, but they remain poorly understood. Some scientists speculate that supernovae, like the one anticipated from Betelgeuse, may hold the key to unlocking some of these mysteries. Supernovae release an extraordinary amount of energy and radiation, and some researchers believe these powerful forces could interact with dark matter in ways we can observe and study. One fascinating hypothesis is that dark matter exists in the form of weakly interacting massive particles, WIMPs. If WIMPs do exist, their interaction with the energy generated by Betelgeuse's supernova could provide crucial clues about their nature. Such a discovery would be groundbreaking, offering the first direct evidence of dark matter, an elusive phenomenon that has confounded scientists for decades. Similarly, Betelgeuse's explosion could provide information about the nature of dark energy, the mysterious force driving the accelerated expansion of the universe. By studying how light and energy behave during the supernova, scientists may gather crucial information about how cosmic events like these influence the universe's expansion and how they might be connected to dark energy. The upcoming explosion of Betelgeuse offers a unique perspective on the life cycle of massive stars that are vital to the cosmic ecosystem. Red supergiants like Betelgeuse are rare, making their study essential for understanding stellar evolution. These stars form from clouds of gas and dust that collapse under gravity, eventually igniting nuclear fusion in their cores. As they exhaust their hydrogen fuel, they expand dramatically, shedding their outer layers through powerful solar winds. This mass loss enhances the enrichment of the interstellar medium, opening the way for the formation of new stars. When Betelgeuse goes supernova, it will not only offer insights into its own life cycle but also serve as a cosmic laboratory for studying the conditions under which stars live and die. Researchers will closely monitor the aftermath of the explosion to determine whether a black hole or a neutron star forms at its core. The nature of this remnant will provide valuable information about the physical processes that govern the final stages of stellar evolution. The dynamics of the explosion itself will also provide a wealth of information. The shock wave produced by the supernova will sweep through the surrounding gas and dust, heating it and causing it to glow brightly. This emitted light will offer astronomers clues about the components made during the explosion, such as iron, nickel, and other heavy elements. By analyzing the spectral signatures of these elements, scientists will be able to determine their abundance and distribution, deepening our understanding of how these elements propagate through space and contribute to the formation of future stars and planetary systems. Another area of interest is the potential for gravitational wave detection. As the core collapses and the supernova unfolds, it may generate ripples in spacetime that can be detected by observatories like LIGO and Virgo. Gravitational waves carry information about the dynamics of the event, potentially offering new insights into the physics of supernovae and black hole formation. Betelgeuse's explosion could also act as a catalyst for technological advancements in astronomy. The expected rise in observational data will likely push the boundaries of current astronomical instruments, potentially leading to breakthroughs in imaging technology, data processing, and real-time analysis. These innovations could benefit numerous astrophysical studies beyond just the supernova. Public engagement will play a crucial role in Betelgeuse's supernova, fostering a sense of wonder and curiosity about the universe. Educational programs, outreach initiatives, and citizen science projects will use this event to inspire the next generation of astronomers and physicists. Schools and universities may organize viewing parties, lectures, and discussions that emphasize the importance of understanding the cosmos and our place within it. As we prepare for this monumental event, excitement is building throughout the scientific community and among amateur enthusiasts. The anticipation surrounding Betelgeuse's supernova encapsulates humanity's desire to explore the unknown, challenge our understanding of the universe, and unite us in our pursuit of knowledge. The death of a star becomes a profound reminder of the cycle of creation and destruction that defines the cosmos, urging us to reflect on our own existence and the mysteries that lie beyond. This celestial drama unfolding in the constellation Orion will be more than just a spectacular sight. It will be a symbol of our evolving relationship with the universe. As we observe Betelgeuse's transformation, we're not only witnessing the death of a massive star, we're also participating in a profound moment of cosmic storytelling, one that links the ancient past of the universe with our present curiosity and future understanding. Historically, humanity has looked to the skies for answers, for signs, for guidance, for meaning. The supernova of Betelgeuse may very well become a defining event of our generation's skywatching legacy, comparable to ancient stargazers recording comets or eclipses that shaped myths and legends. But unlike those times, today we have the tools, the technology, and the scientific insight to interpret the language of the cosmos more accurately than ever before. The data collected from Betelgeuse's supernova will be poured into massive simulations, compared against decades of theoretical predictions, and possibly rewritten into textbooks that the next generation will study. It will challenge existing models and perhaps confirm theories that until now remained only speculative. In a way, the explosion is not an end but a beginning, a gateway to discoveries we cannot yet imagine. This moment also reminds us of our fragility and our resilience. On a cosmic scale, we are small and fleeting. Yet our ability to understand the stars, to build instruments that catch their dying light, and to derive meaning from their final breath, speaks volumes about our species. Betelgeuse's light, when it reaches us, will have traveled hundreds of years through the vacuum of space, uninterrupted, unchanged, only to meet the eyes of curious humans waiting to witness the grandeur of a stellar finale. And perhaps, as the night sky briefly brightens with the ghost of a star, people across continents will pause, look up, and feel connected, to each other, to the universe, and to something far greater than themselves.